Section 3.3, Example 4. A 4-digit PIN number can begin with any digit except 0, and the remaining digits have no restriction. If repeated digits are allowed, determine the probability of the PIN code beginning with a number greater than 7 and ending with a 3. So first of all, we are going to look at our total outcomes. We're looking for a 4-digit PIN. We're looking at digits from 0 to 9, so there are 10 possible digits to choose from. We are told, however, that this first digit cannot be 0. So instead of 10 digits we can choose from for this first position, there are 9 digits that we can choose from. We are also told that repeated digits are allowed. So no matter what number is here, we still have 10 choices for the second number, 10 choices for the third, and 10 choices for the fourth digit. There are 9,000 possible total outcomes. We are looking for the favorable outcomes, and our favorable outcomes this time is we're looking for a PIN that begins with a number greater than 7 and ending with a 3. Greater than 7, that means we cannot have 7. It doesn't say greater than or equal to 7. It says greater than 7. So the only 2 possible digits we can have for that first digit is 8 or 9. There are 2 digits we can choose from. And our last digit must be a 3. So let's take a look at those favorable outcomes. We need a 4-digit code. This first number can be an 8 or 9, so there are only 2 choices. The last number must be a 3. There's only one way to fill that space. And again, digits can be repeated. There are 10 choices for the second digit and 10 choices for the third. If we multiply all of those choices together, there are 200 favorable outcomes. To finish up, we're looking for the probability. Probability is our favorable outcomes over the total. Our favorable outcomes is 200, and our total outcomes is 9,000. We can write that as a fraction in Low's terms, and that can be reduced to 1 over 45. If we write that as a decimal, that's 0.022 repeating. And we can write that as 2.2%.